So let's talk about why proofs are important. And let's take a look at this example here. So we want to know how many regions are formed by connecting random points on a circle using straight lines. So to express exactly what that means, let's take a look at some examples. If we have 1 point on a circle, then there's really just one region on that circle, right? We haven't divided it into any further regions. If we connect 2 points with a straight line, now we have 2 regions, right? It doesn't matter where you draw the line, you're going to end up with 2 regions on your circle. If we have 3 points and we connect all of them with straight lines, right, you're going to see now we have 4 regions on this circle. And if we have 4 points on that circle and connect all of them with straight lines, if we count all the regions, you're going to see we have 8 different regions in this circle. You're probably already seeing a bit of a pattern here, right? Can anybody tell me how many regions we're going to have once we add another point on this pattern? Perfect. Yes, that's right. 16, right? We're multiplying by 2 every time. So we're starting to see a pattern with this, right? And this is what math is. It's just all about finding patterns, right? That's basically all it is all the way through. So if we see this pattern, we may think of a formula for how many regions we get based on the number of points on this circle, right? Notice when we have 1 point, we have 1 region. When we have 2 points, we have 2 regions. When we multiply by 2, multiply by 2, multiply by 2, which means we're probably looking at a power of 2, right? If we plug in the values we have for n into this formula, we'll get 1, then 2, then 4, then 8, then 16, right? So this would seem like an appropriate formula for this problem, but we would be wrong. That's not the right formula. It makes perfect sense for the first 5 cases, but if you just go 1 case further, it breaks down. This is not 16 times 2, right? 16 times 2 would be 32. When you add another point to this circle, you get 31 regions. So our intuition let us down. The real formula for this problem is something a little bit more complicated, a 4th degree polynomial. And we're not going to prove this right now, but the idea here is to realize that math is surprising, right? Sometimes you see a pattern and you think it's going to go on forever, but if you go far enough, it breaks down. That's why we can never just assume that things are true. It's always important to justify whatever work we do when we're working with math, right? So that's why that's why proofs are important, right? They give us confidence in our results. They show that what we've come up with is actually true. So they allow us to know that things are true, right? The difference between knowing that that was a formula or believing it, right, is